there's certain things that we can allow the model to be flexible on, right? Did it say increasing or did it say rising, right? These are soft things. There are other things that we want it to be really, really specific about, right? It can't misquote a number, right? We've got to be able to, if the number is six, it's not seven or five, right? So I think this idea of bounding the uncertainty is it's a really good notion. We've been bounding the uncertainty for a long time in all of our traditional QA testing, but the bounds are very, very narrow. It must be, this kind of answer. With AI and gen models, you get to open that up a little bit, right? Give it a little bit more flexibility on certain things. Did it do A and then B, or did it do B and then A? It's probably okay either way. But there's other things that where we can't really allow it to be flexible, right? We want it to, you know, precisely reproduce facts, or
Where
not
do
even
where do like,
reproduce
where
them,
do
give
companies
references to them. Yeah.
where do you see companies sort of making mistakes here?
With abounding uncertainty, yeah. Well, so this is the classic whack-a-mole problem, right? So what happens is someone will do a demo, an internal in-house demo. Hey, look, I tried this thing over the weekend, right? And then somebody gets excited about it, so then they add a couple more cases and they make a nice PowerPoint and they go to the boss with it. Well, now the boss says, hey, this thing's getting some legs. Let's add a couple more cases and we'll go up the ladder, and eventually it's funded, right? And now we're up and running. The problem is they've never tested the negatives, right? They've never tested the situations that don't work, right? And so this idea of bounding the uncertainties, you got to be able to say yes. When I ask these positive cases, I get the correct answer every time, or even better, I get the correct answer a certain fraction of the time, or the correct answer is allowed to be within this range, right? As opposed to saying, no, it must give me this exact answer. If it doesn't, I'm going to tweak it and twist it. When you tweak it and twist it to make exact answers come out, you're breaking other cases that are more general. When you give it a little bit more range, to give an answer that's a little bit more flexible, you're actually allowing a lot more test cases to work.
Mm.
And so that's something that people miss out on. The tighter you try to make it exactly do the same thing every time, the less likely it is to do a great job generally on a lot of other questions that you're not asking it every time. That's the mistake the customers make.
You need to engineer in controls, right? And I think the right way to think about that, which fits with what Mike just said, is you're not trying to control to a specific answer. What you're trying to do is define a bounded space, right, around what's acceptable, right? And so it is that challenge of, you want to give enough. One of the amazing things about these LLMs is the fact that they're applying intelligence to it, and you get a little creativity, what you might call creativity in the responses sometimes. And sometimes that's some of the benefits of what's happening, is it thinking, in unique ways about this. But you also want to make sure there's a box, right? So I think what you're really trying to do there is test for cases that are um, you know, that are outside of that box, as well as put in validations around to a same thing. So Mike used the example of the answer six, right? It's not seven or eight or five. Making sure that we get this, you know, making sure that it knows to kind of double check its work, with tools typically that you've engineered to validate the conclusions that it's making.
Yeah, I love that point. Just really quick, it reminds me a little bit of the band I hired for my daughter's getting married this weekend, and I hired a band. And
Congrats.
I want them to be creative where they need to be creative. But when it comes to Here Comes the Bride, I want them to play it right on time and do it the right way.
That's right. That's
And
right.
so-
No flexibility on that one.
Yeah.
A quick example I've learned on some of the things where, we build a lot of applications that are analytic based. And so, one of the power of the LLM in this case is it can analyze the results of what's coming out. But, one of the things I learned with this is, so you get a big data set. I actually learned that sometimes taking that big data set and then running heuristic, which means, programmatic analysis around that data set, and breaking it down into a bunch of bullets heuristically around, saying like, this guy was, this group of people were in the top 10%. We had this growth percentage up or down. We had this sort of thing up or down. Not relying on the LLM to have to do that math. So you take these heuristics to deliver these bulleted findings around the data set, and then you give those to the LLM in order to provide interpretive analysis among those bullets. So to pull out, what were the most interesting things from that based on the specific question that the user asked and things along those lines. So is this kind of tuning between, when to feed it more, engineered type information into the LLM so it can use its intelligence in the best way.
Yeah, so you're not trusting it to sort of do the analysis however it wants. You're making sure that's accurate from your perspective and controlled from your perspective, and allowing it to talk about it however it wants within that boundary.
That's right. And it implies some interpretive analysis too, which is sometimes interesting, right? But you kind of are pre-doing a lot of the math for
That
it,
makes sense.
if you make it sense there, right? Which is also where these things can, tend to struggle the most.
And in that category, what mistakes people make a lot here is this idea that you observe a behavior, so then you go modify a prompt with a rule, right? And you tell it there's a new rule: don't ever do this if that happens, right? Now, what you don't realize is that you just made that rule one time. Now 10,000 times when that same prompt gets used, that same rule is going to be there because of this one thing you were trying to do. And by the way, you're not guaranteed that the LLM is going to follow it, because it is an uncertainty machine, right? So this just goes to my overall statement. If you know how to code something, make it possible for your code to handle that situation. Use the LLM when you don't know how to code it, right? And getting to these situations where I love the question that I get a lot, which is, I gave it 100 rules. Why didn't it follow them? Well, because you gave it 100 rules. That's why it didn't follow them. It's sort of like you're stuck in a loop there. I took a picture yesterday. I was on the road. I took a picture. My wife was driving, so but there were 2 arrows showing a left turn was the way that you were allowed to go, and there was a sign saying no left turn in the foreground in front of those 2 arrows, right? And if you do that sort of a thing, the model is not going to know what to do, and so it's going to end up violating what your rules are. So if you have a situation where you have flexibility, and what you need is rigidity, well, LLM might not be the case. That you might not be the thing that you want. Maybe you want code. On the other hand, if you have a situation where there's a ton of flexibility, and what you need is for the LLM to collate that for you into some actions that are now digitized, so that you can take control of it, then that's where you want the LLM to be.